gonna get started because it is 5:30. I'll take the reins for this evening. Simon, if you want to help out with questions and stuff like that. So my name's Peter Hansons. Obviously, we're at the Data Engineering Meetup tonight. When we're not in the middle of a global pandemic, we meet in Brisbane, Sydney and Melbourne at different, facilities, but now we're all online courtesy of Zoom webinar. So great to have you on board. So we're taking questions on Zoom. We've got the Data Engineers Meetup Slack group, and we're also on Twitch. So wherever you'd like to post a question, me and Simon will go and collate all of those questions together, and we'll present them back to our presenters, and we'll see if they've got some great answers for you. You're probably sick to death of me saying this, but have you heard of Data Eng Bytes? It's an awesome conference that we've got going on the 20th and 21st of August. It's a conference for the community, run by the community. So we're all data engineers. We don't have any sort of massive sales pitches or anything like that. We just kind of like to learn a whole bunch about data engineering. So if that's your jam, then do please come along. I think it's going to be a bunch of fun. We're pretty close to selling 400 tickets, and I think we're going to sell a whole bunch more. Got amazing speakers. We might just, in the interlude between the two speakers, we might sort of take you through them as well. But before we get to Data Eng Bytes, we've got an awesome August edition of the Data Engineering Meetup with Helen Anderson. She's an AWS Data Hero and also a product specialist at Raygun. And we've also got James Gollan, Senior Solutions Architect at Confluent, the makers of Kafka. So yeah, that's pretty much it. We're going to get straight into Helen's talk. She's joining us all the way from New Zealand in Wellington, where they're completely COVID free, which is pretty amazing. And they've got gigabit internet, but Helen has a few sort of sketchy issues with her internet connection tonight. So we'll try and work through all of that, but it should all be fine. And then at around 6:15, we'll dive into James's talk, where he'll take us through streaming ETL with ksqlDB, bring your own functions. That sounds really cool. So, but first up, we've got Helen. She's going to be talking us through, DMS and other sort of things like that on AWS, migrating from SQL Server to AWS Aurora, but also the human element of all of that. So I'll let you take it away, Helen. Thank you so much.
Oh, thank you. I'm just going to share my screen and cross my fingers. So can we see a penguin? Are we good? Maybe.
Coming, nearly. Did you share your screen?
Yep. Maybe I should have had some jokes prepared or something, just in case.
Yeah. Maybe what you might want to do is stop your video, and that might save a bit of bandwidth as well.
Yeah. Technology is hard.
Yeah, the internet's. Okay, the screen's up. Feel free.
Oh goodness, I can't hear anyone. Are we good?
Yeah, we're good to go. Can you hear me, Helen? Yeah, just feel free to take it away.
Cool. All right. Yeah, thank you for the lovely introduction. Yeah, my name's Helen, and tonight I'm going to be talking about both the technical side and the human side of a database migration project that I was a part of. Before I get into that, a little bit more about me. I'm coming to you from Wellington, New Zealand, and I'm a product manager at Raygun. We build dev tools for dev teams. But before that, up until about 2 months ago, I was at Xero Accounting Software. This is where this project has come from. You can also find me lurking around the internet on Twitter, I've been an AWS Data Hero since late last year. Now, when I go to data-related meetups, I see slides with lots of architecture diagrams and airflow diagrams and lots of Python code, and all this is great stuff. Don't get me wrong, this talk has plenty of that too. But sometimes I feel like we lose the human element of all the great data things that we do. Because we're not just data plumbers. The reason that we do what we do is because there's people who need the data that we move around, that we enrich, that we present. So what I'd like to do is to focus on both the tooling and the teamwork. And what I'm hoping that you take away from this is that migration is a team sport. On this project that I'm going to go into, we couldn't have done it without the buy-in from the folks that we were doing it for. And it's just important as the shiny toys that we get to play with to get it done. So to set the scene a little bit, this story takes place at a time when Xero had just moved its core platform to AWS. And this change in infrastructure gave the BI and data engineering teams the opportunity to embrace the benefits of the cloud as well. So we had migrated to a Redshift data warehouse where we store all the raw data that we move from the product. And we enrich it, create our data models, and then have our visualization tool over the top. So anyone can come along and use these dashboards, and that works pretty well. But there was one database in our account which hadn't quite come to the party yet. This SQL Server database supports data analysts and other teams around Xero who need data in a queryable format, who aren't so interested in dashboards, but want to blend data in and sort of do their own thing as well. With our move to Redshift, we saw the opportunity to deploy something better, something that would suit the growing data analyst community's needs. So what I'm going to take you through are the growing pains that we faced as the analyst community grew, and why we decided to go with Aurora as our replacement for SQL Server, how we communicated this project to more than 60 data analysts across 4 time zones, the design challenges we faced along the way, how we managed to gently nudge the migration along, which isn't always an easy task, and the success we had at go live stage. So when I joined Xero back in 2015, the analyst community was much, much smaller. At that time, we were 4 marketing analysts here in Wellington, and there were another 4 around the world. In 2015, at least in New Zealand, data science wasn't the hot job it is now, and data analysts used the database to pull lists for email campaigns. By the time we reached 2017, the community had grown to about 20, and the amount of data that was being stored on disk was growing every few months. And there was this kind of general feeling that queries were taking longer and longer to return. And then fast forward to 2019, and there's well over 60 data analysts. We had just rolled out a data lake for the data scientists. So we saw the opportunity to build something for data analysts that was a bit more modern. So the Redshift data warehouse was restricted to just the BI team. So analysts and other teams who wanted to use this data had to wait until it was transferred to SQL Server. Due to the amount of data, this was a long and drawn out process. And we had complaints that there wasn't enough visibility of when the process would finish. Aurora provides us with the efficiencies we need, and it's less expensive than SQL Server licensing and disk. But before we could start solutioning a new environment, we had to make sure that there was shared understanding for the analysts and the BI and data engineers. Migrations within our own team had been tricky enough, but this one had added complexity. We had more than 60 users in 4 different time zones, which made it a real challenge to schedule meetings, keep the communication going, and generally get people on board. And due to Xero's growth, there was more analysts starting each and every month. Some only had Excel experience, some were experienced SQL users, and then we had the data scientists who were more at home with the data lake and more exciting toys, but needed to do the occasional ad hoc query. To get everyone on board, we scheduled monthly workshops with key users, created a dedicated Slack channel, and focused on making the environment as accessible as possible. But there were some design challenges, and took stock of the SQL Server that we were dealing with. Because the SQL Server environment was designed as a sandbox, there were legacy tables, plenty of tables called test, as you do, and just schemas of objects that no one seemed to own, that dated all the way back to 2015. But through a huge amount of effort and some gentle nudging, we managed to clear out 2,500 tables and free up 2 terabytes of disk, which was really satisfying. And luckily, only one analyst popped up asking if the table back. So after cutting down the most that we could, we started to look at moving the data around. So the challenge was to replace the mechanism that we used to move data from Redshift to the analyst database every day. With some tables being billions of rows deep and others hundreds of columns wide, this wasn't an easy task. And having to translate all that data from Postgres to a SQL Server, yeah, we just needed some more efficiencies around that process. So we decided to use DB Link, which is kind of like SQL Server's open query that allows us to access tables between databases, and then Apache Airflow as a scheduler, which removed all the complexity in 2 different types of database, and the copy time has gone from 12 hours to just 2. Our third challenge was to find a scheduling tool the analysts could use to schedule their stored procedures. Aurora sadly doesn't come with a built-in job agent like SQL Server, so we needed to work through other possibilities. We tried using cron jobs, but they're not particularly beginner friendly. So then we considered standing up an Airflow server for the analysts. But with each new job, you need to restart it. And this could have been a total disaster with analysts across 4 time zones interrupting each other's jobs to get their own scheduled. In the end, we decided on what was already there, which was Windows Task Scheduler, as the analysts were pretty familiar with it and it wasn't going to disrupt anyone. And the last major design consideration before we get into the good stuff was around security and setting functional groups. So the way we had set up SQL Server, and I appreciate this isn't ideal, meant that everyone could see everything and everyone had the rights to potentially delete anything. So we made the conscious decision to create a schema for each functional group, so they had a dedicated place to write their own tables. Marketing analysts could share with other marketing analysts, and this is in line with data governance policies and the fact that not everyone should have access to everything. So unlike a traditional database migration, we had some tools from AWS to make things faster and easier. The schema conversion tool is designed to convert the entire database with all the keys, constraints, the data types of columns, indexes, the whole lot. And then the database migration service is a tool which moves the data and lands it into the perfectly created tables that we've created with the schema conversion tool. And as I'm too chicken to do a live demo, I've got a screenshot from the docs, which shows the dashboard that lets you select a schema or table from the source, which is what's on the left-hand side. And then with a few clicks of a button, creates a new table on the right-hand side, which is the new database. The tool also gives you the option to the tool gives you an action plan. So it figures out how difficult the objects are going to be to convert. So for us, there were some stored procedures which had some funky syntax, which just didn't work for Postgres. So there was a bit of manual intervention to be done. But all in all, a pretty easy process. Once the table is converted, it really is just a click of a button to apply to database, and then it's created on your Aurora side. And then the database migration service, which syncs in nicely with the conversion tool. This is another easy to use point and click tool, which is all done in the AWS console. You create tasks using table mappings, or you can import JSON to tell the tool where you want your data to go. So in this nice screenshot, we're picking up everything from the schema called customers and the schema called orders and putting it into the other side with a prefix added to the schema name. So you can do transformations as well if it's not named the same on the other side. Again, a very easy tool. And just point and click in the console and you're done. You can see the data loading on this nice table here. And I didn't notice when I pulled this screenshot, but it looks like elapsed time is 26 days for some of these. Ours did not take that long. I think it took like a couple of minutes per table. So a really quick and easy tool to use. So despite going through some challenges and some thinkings around designing the right environment, we went from gathering requirements to user training in just over 6 months. And that's all great, but building an environment in isolation is very different from letting users loose. There's new syntax to get to grips with, less experienced analysts need more help, and then these queries that hit the tables all at once. So we spent another month doing testing with key analysts and then let everyone in a few at a time. And the nice thing is that when you get people on board, they give you nice feedback. And I'm not just sharing this to make myself feel good, but to highlight that by having everyone on board and being involved in the process, they felt like they were coming towards something good, and it was part of their lives as well. So the analysts really got stuck into the new system, got to grips with the new UI, and then trained each other, which was really good to see. The copy time reduced from 12 hours to 2, and then the analyst queries were coming back much faster as well. And we documented everything. I know documentation isn't the sexiest job as part of being a data engineer, but by getting the BI, data engineering and analyst community all involved, it came together really nicely and everyone can help each other. If you're interested in making the move to AWS, I'd recommend getting started with the free tier and having a play around with the tools. Aurora comes in MySQL, Postgres, and serverless is also available if that's your thing. And after that, it's just a matter of setting up users, security groups, and yeah, you're good to go. With AWS being a managed service, data engineers and DBAs are freed up from the day-to-day maintenance and things, which is also a big win. But it's not just about the tooling, as migration is a team sport. So we had the community of analysts behind us, and it's encouraging to see them take to the environment so well. By listening to them and moving at a steady and slow pace, we tackled everything in just 9 months. Cool. So that's the end of my database migration story. Yeah, happy to take any questions. And hopefully my screen didn't freak out too much.
No, that was really awesome, Helen. And yeah, thanks so much. Might get you to switch your video back on if your internet connection, if you're brave.
Brave enough.
Yeah. Well, so we have actually had a question come through. Buku said it was a very interesting presentation.
Thank you.
Aleba has asked, hi Helen, was it a cost-effective move for you, the move to Aurora from SQL Server?
Yeah, definitely. Yeah, the SQL Server licensing wasn't so expensive, but it was the disk that we had to pay for underneath that was costing a fortune. And I think that was partly because there were just so many legacy tables hanging around. But it is nice to have everything all in one account. And yeah, Aurora just being so much faster and easier to use, just, yeah, made it a no-brainer.
Yeah, question from me. You know, you talked about, I guess, you know, AWS and, you know, like I'm a bit of an AWS fanboy, but, you know, they've got a lot of tools, you know, to make things easier and, you know, but any vendor will have a ton of tools to make it super easy to get onto their platform. That's just, you know, how it all works. But, yep. You know, I guess, you know, putting that to the side, sort of, what did you feel like was your biggest challenge? Was it that, you know, sort of getting everyone on board and sort of being able to adapt to, I guess, a new way of working, you know, using a new database and stuff like that? Tell us a bit about that.
Yeah, I think, yeah, the reason that I made the point that, yeah, the technical and the human side are just as important is because both of them give you the highest highs and the lowest lows. So playing with the new toys is always really fun. Encountering errors and bugs and things in the new toys is not fun. And then getting everyone on board can be a bit of a challenge, especially with time zones in my case. But seeing everyone at the other end taking to the new tool and giving us all the good feedback and then contributing to the documentation was just such a win. It's really heartwarming stuff.
Yeah, that sounds like it was a really great project to be a part of. You know, you're able to really sort of involve everyone, and everyone took a lot of ownership. So congrats on that. You know, they're not always super successful, so you know, well done. There's another question from Vinay Reddy. Hi Helen, thanks for the preso. My question is, I've never used Redshift. Can the analyst community can't use Redshift for querying? Just the way that it was written, why there is a need to SQL Server?
Yeah, I think I can kind of get the gist of this one because I've had it before when I've done this presentation before. So the Redshift database is just for the BI team because we've got MicroStrategy as our visualization tool over the top and we need to keep it to just for that use. So it's nice having 60 other people who aren't in your team, who you don't know what they're using it for, you don't know what kind of code quality you've got going on. So it's nice to kind of isolate that. So all the work that the BI team are using Redshift for is kind of kept separate. So that's why we had the Sandbox SQL Server and now the Sandbox Aurora.
Yeah, nice. Well, yeah, that's very cool. Okay, so Matt's asked, did you explore any other options outside of AWS?
We did explore other options. We did consider putting everyone in the data lake or data swamp or data puddle or whatever it's called these days. But it was a challenge with especially new analysts who are just coming off SQL, off Excel, and it's taking their first steps into the SQL world. It's kind of a bit kinder to leave them with a database and let them upskill to all the data lake type toys later. Yeah, we definitely were going to stick with AWS since the whole company is using the same. So
yeah, if I can make a comment there, I think, you know, like, I mean, just like focusing on, say, AWS tooling, but, you know, AWS Glue can be quite a step up if, you know, if you're just coming from, say, just a SQL background. I think, you know, Zero is a AWS shop, like a lot of your,
100%.
So I guess it made sense to sort of consider a lot of AWS focused things, but that's not to say that, you know, there's not plenty of other great options on other clouds or whatever.
Yep, absolutely.
One last question before I let you off the hook. Vinay's asked, how is the data being loaded on a daily basis to Redshift? Is that DMS or what are you doing there?
That is still custom code. So we've got a couple of homegrown options that are working on that. But we do have, well, I'm no longer at Zero, so this is probably the last time I can give this presentation, but I'm told that there's some modernization in the works happening there, so it's no longer so custom.
Yeah, because Redshift's not a target for TMS, or?
I think because the application databases are sort of all different kinds of systems. So we've got Salesforce and the application databases. There's a couple of Dynamo bits and pieces hanging around, so they're all sort of different. So yeah, DMS isn't always the option.
Yeah, no, that makes a lot of sense. Yeah, cool. Simon, can I put you on the spot and trouble you to tell us a little bit about Data Eng Bytes?
Oh, how long do I have? I'm so excited about this data engineering conference. If you are the kind of person who's at all interested in data engineering or any of the periphery areas around data engineering, such as analytics, storytelling, visualization, event-driven architecture, Data Engineering Conference is absolutely the place you need to be. It's on the afternoon of Thursday the 20th and the morning of Friday the 21st of August. We've got 18 amazing speakers. Check out the speaker conference list and you'll see the incredible caliber of speakers that we have. Now, you might be asking yourself, this sounds amazing. How much money could I possibly spend to get access to such amazing speakers? And I'm going to shock you for a moment. This is a free conference. All you need to do is register and hold the time. Now, we have incredible speakers. We've got Zamak speaking about data mesh from ThoughtWorks. We have Gollan talking about some really, really cool concepts. And we've got some incredible local speakers and international speakers. So if you're the kind of person who's at all interested in data engineering and want to learn from peers who've gone through some interesting journeys around the technology, the process, and the human element around data, data at rest, data in motion, and streaming data, Data Engineering Bytes is absolutely the conference for you. Again, those dates, 20th, 21st of August, and I'm really looking forward to it. And that website on the screen, follow those links, get yourself a ticket, and spread the word, because we're super excited to have this as a community-led event. We're really, really excited about some of the speakers that we have, both Australia and international, and absolute hats off to the amazing involvement and support that we get from these fine sponsors that are on the screen. Data Engineering Bytes, really looking forward to seeing everyone there.
Thanks so much, Simon. So massive shout out to all of our sponsors here tonight, like Snowflake, MongoDB, Databricks, AWS, Microsoft Azure, Fivetran, Confluent, ThoughtWorks, Instacluster, Canva, conferences, and Cloud Shuttle. these things don't happen without sponsors. So we're absolutely super grateful for their contribution. So thanks so much. All right, without further ado, though, we've got James Gollan from Confluent taking us through a pretty cool bring your own functions with ksqlDB talk tonight. So James, are you around, or get your videos?
I am here.
Very good. Would you like to take it away? You should be able to just start sharing your screen whenever.
Yeah, absolutely. Thank you, everybody, for the opportunity to talk to you. We've had a disastrous sort of like start to this. So if you hear echoing audio or any other screen sharing issues, I mean, I've been living on Zoom for the last 3 months, like I'm sure everybody else has. You'd think I could manipulate this medium, but I'm just going to actually share from my iPad, and we're going to try some digital whiteboarding to get through these concepts. So it won't be a moment. Okay. All right, so, it seems to be working. Great, so look, what I wanted to go through this evening was an agenda around, the talk was titled Streaming ETL, and it's all about kind of like data transformation in real time. So the agenda is, I want to spend like just a few minutes on what is Kafka. Now, when I saw Simon sort of like join the panel, I'm like, okay, you guys probably have heard a much better talk about what is Kafka, but I'm going to give it a go anyway. And it's good to just like set up the sort of like establish what Kafka is, how we say it playing a role in something like streaming ETL. And then we're going to go and talk about ksqlDB. So that's the crux of this talk. And we're going to discuss why ksqlDB has been developed, what its features are, but then we're also going to have a look at how can we actually extend those features using UDFs. Once we've extended it, what are the possible use cases? And finally, if we get time, and like I think I'm going to be a bit time poor actually, but if we get time, we might talk around some deployment options. So with that said, I'm going to start with that topic of what is Kafka. Now, Kafka is an event streaming platform, and the first thing that sort of introduces is what is an event. Now, an event, we like to think of it as something that happened, an actual fact, an immutable fact. So once it happens, it can't be changed. And to be more specific, it's probably an event is something that happens within your business that actually has this idea of business value. All right, so it's something that defines how the business is going. You may think of it as data, but we like to be quite specific about it being an event. Now, Kafka takes that approach that the world in your business is made up of a series of events. So the central abstraction inside Kafka is this idea of an event log. And so an event log is like any other log. It basically is append only, and it stores, and it's not modifiable once you actually have stored an event. So remember, we thought of events as facts that were immutable. The event log treats them like that. And so we basically get an events are dropping into this event log, and they keep going. It's unbounded. So when a new event happens, it just gets added on to the end of this event log. So we get a new event dropping in there. All right, so that's the core kind of like concept behind Kafka. So how does this relate to streaming ETL and data transformation? Let's just take a little sort of like look at a standard streaming or streaming ETL pipeline. Sorry. That's not going to work. Okay. So we have Kafka here in the middle. And let's say we have your data stored somewhere. Let's just think of this as a database. I might zoom in a bit. And so this might be something like Oracle. And this is essentially the extract part. All right. So you've got your data in Oracle, and you actually want to get it out of Oracle and push it into Kafka as part of, let's just say, this ETL pipeline. So to extract from Oracle, we use these things called producers. So a producer is anything that produces data into Kafka. And so here, we may have kind of like a producer that is essentially using some change data capture, so that every time there's a change to the Oracle database, that is actually captured in real time and pushed through into Kafka. So Kafka starts to build up this notion of events, right? So these things that happen in Oracle are converted into events through change data capture, and then they are stored in what Kafka refers to as topics. But topics really are essentially just that commit log we were talking about before. So events always end up at the end, and then they can be read by consumers. So the next part to this notion is the idea of you want to move that data somewhere. All right. So like we're actually thinking of this as, say you've got a data warehouse. Okay, so the sort of like the minimal kind of viable ETL, if you like. And so this part is actually the load part. So we're taking data out of Kafka and pushing it into the data warehouse, right? So now we've got this pipeline, we've got the extract and we've got the load. There are elements to this. You may be looking at this and thinking, oh, well, okay, I've seen this before. He's describing a message queue. And that's part of what Kafka does. It certainly can be used like a traditional message queue. But a bigger part of this is the fact that we have persistence. Okay, so these events actually live for as long as we like. And actually, there's been a recent release to introduce infinite storage. So it's tiered storage in Kafka. So you can keep these events for years at a cost-effective way. But anyway, going back to this idea, we've got the extract and we've got the load. What about the transform? And so that's where we're sort of going to be talking about tonight. So we have here this notion of transforming that data. Now, a transformation in Kafka can be thought of very simply. And so Kafka will listen to events in a topic as they come in real time. And then we will do this transformation. And then we will write back to another topic in Kafka. So Kafka, like a lot of great software, it uses this really simple idea and it reuses it throughout. Okay, so in Kafka, everything is an event that's stored in a topic. So when we do a transformation, we listen to one topic or more than one topic, and then we actually write it back into Kafka. So looking at this transform, what are the options for transforming in Kafka? So there's really three main options. One is you completely write your own client, okay? So that would be dealing with kind of like talking to Kafka. It may use the producer and consumer APIs, but you would be doing all of your logic inside that client, and that would be doing your transformations and writing back to Kafka. Now, Kafka pretty early on in 2015, I think, 16, introduced a case streams API. So the streaming API essentially allowed you to build Java applications that would do the same role as the client, but at a higher level of abstraction. So rather than having to write lots of code around streaming transformations, that was available to you through a Java library. Okay. And that is still in use today. People use that, and it's a very mature API, and it's very effective. But what we did find is that both of these approaches actually had some drawbacks. And one of the main drawbacks is you actually have to write these things in Java, then you have to compile them, Then you have to upload them. Let's just say deploy them. And every time you wanted a new transformation or to modify that transformation, you actually had to go through that process again. So this is kind of like the negatives of these processes. And that's where ksqlDB sort of like comes in. So ksqlDB, rather than being something that you build in Java, it's actually an application that is essentially an abstraction over k-streams. And what it does, the reason it exists, is because rather than having to write code for all of your transformations, it gives you this SQL-like syntax. So this is really important because now, rather than being a developer, if you're familiar with SQL, you can actually start to write transformations. And these are real-time transformations that will actually operate at scale. And Kafka, something I didn't mention, Kafka operates at insane scales. So I actually heard there was a release today, somebody was talking about TikTok, and TikTok uses Kafka. They're dealing with 10 trillion events per day. So that's kind of scale we're talking about here. And so what ksqlDB does is it really simplifies the creation of these streaming transformations. So let's have a little look at what we're talking about in terms of how these various approaches look. So to start with, if you were writing your own Kafka client, and we've got the same example here actually, I've got the 3 different approaches. It's the same example. All we're doing is is listening to a topic, creating a running count, and then writing it back to another topic. So with a Kafka client, you have a whole lot of code that you have to do at a very low level to talk to Kafka and create this count right back. Using the ksstreams API, you can see it's much, much simpler, all right? So a lot of the code, a lot of the heavy lifting is being abstracted away. And so here, this is still being written in Java. It still needs to be compiled and uploaded to the server, but it's greatly simplified. But when we bring in ksqlDB, I think a lot of people will start to actually kind of recognize, you can actually read it and you can tell what it's doing. So here, we're basically doing a grouping query and creating a count. So that's how simple a real-time streaming transformation can be made using ksqlDB. Now remember, this actually in the background, this compiles down to a ksstreams application. So this will run at incredible scale. So don't let the simplicity fool you into thinking it's not sort of production grade, because this will run in production. Now, one thing that I did want to point out, you know, the whole select and the count. So the count obviously is a built-in function. The thing that may not be obvious or may not be familiar to most people is this emit changes. And so what this means, this is the difference between just a sort of a SQL query, which is run against a relational database that runs at a point in time and returns results that are valid at that point of time. Emit changes is actually a nod towards the fact that this query will be running continuously and it will be listening to topics. So tell me if anybody gets motion sick here. So the query will actually be listening to these topics. And when a new event arrives at the topic, the query will rerun and update all of the, basically update the results. So that's the difference between a real-time query and a streaming query. So I think what you can see here is like, I mean, hopefully sort of like what I've drawn out here is this notion of kind of like real-time streaming ETL. Now, we said that there were advantages to ksstreams. There are also disadvantages. And the main disadvantage is because, sorry, ksqlDB. The main disadvantage is because it's a very sort of generic approach to query building, it actually is limited in terms of what you can do easily. So it comes with a whole range of functions. The functions are actually quite similar to that you would see in sort of like a SQL language. So just dropping into the the documentation site, we can see a list of these functions, right? So we can see all of the functions that are exposed by the language. And so there are various types of functions here. Some are simple scalar functions, and some are grouping or aggregating functions. To have a look at what one of these queries looks like, we can actually see a couple of queries here. So the first one is a query that is essentially looking, this is the basis for kind of like real-time fraud detection. So it's essentially creating a query which is windowed, so the concept of time comes in with real-time streaming. So it's a query that is looking for a credit card with the same number that's tried to be authorized more than 3 times in 5 seconds. And remember, this runs in real time, and this is where banking are using Kafka for that real-time fraud detection. So the old approach was kind of like, batch process overnight, which basically means you get an email saying, oh, yesterday your card got, your card was used to charge something that you didn't charge for. So you can see the business impact of actually having these queries running at real time. The next one is a slightly simpler query in a sense, where we're actually just using ksqlDB to actually find the 5 highest value orders by a particular postcode for the last hour. And so remember, because this is a streaming query, this will update every hour. Okay, so you can see that you can actually do quite a lot of useful things using ksqlDB just as it is. But moving on to sort of like the final part of this talk, I guess, is around that idea of what we call UDF or UDAF. So UDF stands for user-defined function, and UDAF is user-defined aggregating function. Essentially, what they represent is a new feature in ksqlDB where we now have a UDF API, which means that you can actually extend the language. So how do we extend the language? Well, we do it, I suppose we're back to writing a Java class, but this time we're writing it once, and then that function will be available within the language to be reused across the organization. All right, so based on that, what I'm going to be looking at is a fairly simple use case. So, and this was actually a real world use case. I was getting log entries, okay? So they were Nginx logs actually, and they had been configured on the source system from Nginx. And they were basically in a string format. So the entire log was just one long sort of like string with, there was space delimiting, but it wasn't meaningful. There wasn't tab delimiting. It was very difficult to actually parse that log. So we essentially had these log entries. They were coming into Kafka. So they're coming into Kafka. But then in order to do anything useful with them, we actually had to extract the details out of that string. And using the built-in functions, it was difficult, potentially impossible, to actually transform that string into what we wanted, which was a structured object. Okay, so something which actually pulled out the components of that log message. And so I built a UDF that would actually take that string as an input and then output a structured object, which then would be pushed back into Kafka and could be transformed, could be queried much more easily. So I'm just going to jump over to the code for that. You may not, I'm not sure how codey this kind of like this meetup is. You probably hate Java code, it's probably all R and Python and cool things like that. But I'm just going to like point out a couple of things about this code. First of all, when we actually work with, when we write this class, we want to import certain libraries, okay? So these are the UDF description, etc. That's actually allowing us to expose this code to ksqlDB as a UDF function, all right? So the way we do that is through annotations. And then after that, we can see I've got some schema classes in there, because remember I said that I start with a string, but I want to return a structured object. So I need to actually build out a schema within my class to return back to Kafka. And the final things are just to bring in the regex libraries so that I could actually parse this log. So moving down the class, and I won't go into the details of the code, but just the pertinent things. The first thing is the annotation UDF description. And so this is how we actually tell Kafka that this exists and what name we give the function. All right, so this is at that class level. It's a UDF description annotation. And so probably the important thing to see here is this parse nginx log, which essentially is the name that our function is going to have within ksqlDB. Okay, moving down, we've got the main part of the class, and we can see another annotation here. I can select it. Yes, I can. So here is kind of like a method annotation. And so this actually says, this method is actually going to provide back a structured object. So this bit here where it says schema, this is how we're going to break our string down. So I'm going to actually break it down into a structured object with IP address as a variable of varchar. So essentially a string, date stamp, etc. All right, so we're going to be returning a structured object. Finally, we have kind of like an annotation in here around the parameter. So what we've done here is we've exposed the class itself to ksqlDB. We've exposed the function to ksqlDB. Now, then we do some regex. So obviously we parse that string through regex to extract the useful components. But the next thing that I need to do, because I'm returning a schema-based object, I need to define the schema within my class. All right, so essentially what I'm doing here is using this kind of like schema builder object to actually create the schema that I promised ksqlDB I was going to return. Once I've built out that schema, I can build my new structured object from that schema. And then I just use the results from my regex to populate that object. And then finally, I return that object. If my regex failed to find any matches, I'll return null so that the system can continue to process, but I can also write a message that will appear in the Kafka logs. Okay, so that's the basis for kind of like for the UDF function. And so what you do then is you compile this down to a fat jar. All right, so all of the dependencies go in with this function, and then you upload them to an extensions directory on the ksqlDB server. All right, so the process really is you write your Java class, you use those annotations, you compile it down to a fat jar with all the dependencies, and then you upload that to the server. You restart the server, and then the function will appear within your ksqlDB CLI. Now, before I go and do the final demo of showing this actually working within a Kafka cluster, one thing to point out, obviously this is a fairly trivial example, not totally trivial, but fairly trivial. But what we've defined here is a way of actually exposing ksqlDB to any of your custom logic. And some of that custom logic increasingly is models based on machine learning. So a very common use case in ksqlDB is to take your trained models and compile them down to a class, wrap them in a UDF, upload them to the server, and then suddenly, using a SQL-like syntax, you can actually apply your machine learning models in real time within your Kafka cluster. So this is a simple example, a bit contrived, but the implications are much broader. Anyway, now I need to try to swap over. I'll see if I can just share my screen. And oh, that's probably nicer than I expected it to be. And okay, so I'm just checking that we are Can everybody? Yes, you can. Good. So what I'm looking at now is the Confluent Control Center. Now, ksqlDB is licensed under the Confluent Community License, which is essentially like Apache, but and sorry to our AWS speaker, but it's something that can't be run as a service by the big cloud providers. So I'm just going to dig in here quickly, and you can see I've got ksql running. And I've got a ksql cluster, so I'm going to go in here. First thing I'm going to do is just type in show functions. And so what this does is it shows all, it will run a query that shows all of the functions that are available within this instance of ksqlDB. Now I'm just going to look for nginx, and you can see here I have this parse nginx log, which is the custom function that I wrote and uploaded. Right, so that's the first thing. But let's talk about this streaming, this sort of like streaming flow, if you like. So going back to ksqlDB, the ksqlDB application, I can take a look at this flow builder. Come on, come on, come on, come on! Don't do this to me. Let's say, okay, we got logs streaming. My Docker instance may have gone to sleep. Okay. Well, we can look at what's actually going on via the topics. So this should still be working. So to start with, my logs were just coming in to a topic here. And we can see the messages that were flowing through, and they are actually flowing through in real time as we speak. And so I can actually go in and have a look at what these messages look like. And what we can see here is a log message, which is just a big long string, right? But then using ksqlDB, I have a query that's running that's applying that parse nginx log function. And so that's going to actually appear up here in logs structured. So looking in at logs structured, if I go in and have a look at how these queries are running through, they're moving quickly, little queries. If I take a look at what we're getting back, remember it was a string input, but you can see now that I've broken it down into a very structured object, all right? So what that means I can do now, I notice that I've got an HTTP response code here of 200. But what about the pages that didn't respond 200? How can I filter those out? Well, by using another ksqlDB query, I can actually generate entries that are going into bad requests. Now, I know a non-200 request is not necessarily a bad request, but we could equally say, okay, well, just show me 500 errors. So if I now look at the results in this topic, what I can see is I'm getting kind of like particular fields where the response code was not 200. So I've gone from a string, which would be very sort of like hit and miss, whether you could do sort of string matching on that 404. I've gone to an object where it's much, much more reliable. I am so disappointed that we can't see the flow view, because it shows a really sort of like, it shows a really great, yeah, it shows it really well. But here we can see kind of like the queries that are running. And so you can see that this is written in ksqlDB. So again, it's a language which is fairly easy for non-programmers to understand if you've got a background in kind of like a data analytics. I think I am right at time. So look, I may stop there for any questions or for Peter to round it out.
I mean, you've got a bit more time, but I can appreciate, you know, demos, you know, when the demo gods are not on your favor or whatever, then it can be tricky, but it was all running. There was just one screen that just makes it look nice. So that was actually all running in real time. Like there were hundreds of messages sort of like per minute running through that system. Yep. Yeah, nice. Simon, did you want to take the questions, or we did have a few in the chat. I think there was one. Does Kafka manage the ordering of events? I'm thinking, say, multi-topics, multi-brokers and stuff like that.
Yeah. So Kafka, like, yes, you can get guaranteed ordering of events within Kafka, but it's at what we call the partition level. So a Kafka topic is actually broken up into partitions based on the message key. So you have to think about how you're going to structure those message keys. But once you've done that, you get a guarantee of ordering within those queues. Yep. Oh, sorry, that was for Simon, wasn't it? I should be quiet.
Oh, no. I was going to get Simon to ask you. I know Simon could probably, but you're the presenter, so Simon can
stick with formality. Yep, sure.
Yeah.
No, it was a really good presentation. I was just skimming the chat log. We had a question, which I'm going to rephrase something. Can you use ksql within a UDF function? It was written a KUD function, but I assume the question is, can you use ksql within a UDF?
That's very sort of inception-y. Not really, because at that point you're in Java. Like, yeah, it's probably not, unless Simon, I'm wrong. So
I'm gonna ask a reverse question, because I think ksqlDB and Kafka are amazing. Having the extensibility of UDFs and UDAFs are incredible. But maybe you could give us some advice on when you shouldn't use UDFs. What's a bad pattern, or what are some of the signals that UDFs are not the best solution to your problems?
Look, one of the sort of like the anti-patterns, if you like, would be if that UDF is then calling synchronously another service. So so you're introducing the potential for lag there. And so that's where we would say rethink your event streaming architecture, because you could probably expose whatever that service was doing as a topic within Kafka, which then could be processed in real time. Other than that, like, I mean, I guess the main reasons you want to extend ksqlDB with these functions is if they've got sort of like reusable, reusability. So if there's relevance for these functions across multiple transformations, it makes it very easy to reuse. Whereas a K-streams application really does one thing. And if you want to use it again, you need to deploy another K-streams application.
Yep, I think that's super good advice. I think I'd agree to everything you said. And I might just give the more general advice of, if you're doing database migrations and you've got a 5,000 line stored procedure in the depths of SQL Server or Oracle, don't think that that's a good use case for ksqlDB. Don't migrate huge stored procedures into ksqlDB as UDFs. You can, but you probably shouldn't.
A nice tie-in too.
Very good. Well, that was an awesome presentation, James. And, obviously, there's a lot of interest, and Simon's obviously sort of been beating the drum about ksqlDB at the meetup. So good on him. And no, but it's great to see all the great use cases. I think, fraud detection, and things like that, doing it all in real time. So many great use cases. I'm sure we're going to hear a bit more at Data Eng Bytes about ksqlDB and other great streaming technology. So thanks again for coming along and presenting, and hope to have you back soon if you've got another awesome presentation up your sleeve. Anyway, that's pretty much it for the night. Obviously, Data Eng Bytes, you can go to our website, dataengconf.com.au, to see all of our great speakers and get yourself a ticket if you haven't. Otherwise, thanks for coming along. As usual, running the meetup on Zoom. We've got our Slack group and Twitch. We've also got a YouTube channel. So speaking to your future self, if you didn't make it tonight, you can always catch us there. So we'll see you then. But from me and the rest of the team, thanks so much for joining us, and we'll see you next time.